So 0.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
All
and
right.
all through elementary grade, anytime something was times by 3, I would sing that song in my head.
You know, that one just hasn't made it into the popular culture, but I'm sure you'll be the one to take it there, Science Mom. I'm Math Dad,
I'm Science Mom.
and today we're talking about factors and multiples.
And prime numbers, too.
Indeed. But before we get into that content, let's go over our warm-up problem where we were supposed to make the number 3 using a 5, a 1, a 2, and a 2.
And I did it by taking 2 divided by 2, which is 1, and then 5 minus 1 minus 1 is the same as 5 minus 2, which is 3.
I like it. Nicely done, Science Mom.
Thank you.
I came up with another way of doing it. I see that if we were to do 5 minus a 2, so that would get us to a 3, right?
Mm-hmm.
And then if we multiply that whole thing by the number 1, which I'm going to write as a 2 minus 1, well, that equals 3 as well.
Oh.
Okay, and I think I even saw yet another way. What if we were to do 5 plus 2 minus 1, and then divide all of that by 2? So that would be 6 divided by 2, which is 3.
Gotcha. Nice.
Yeah. So if you came up with another solution, we'd love to read it down in the comments. All right. What are the multiples of 4? Basically, if we wanted to count by 4s, what are the numbers that we could get? Those are multiples.
Those are
of
multiples.
4.
So
Yep.
1 and then 4.
Nope,
and
not
then
1
8.
actually. So
Not 1.
Nope, we're actually going to
Just
start
4 and 8.
Yeah, we could start with 0 if we want, but then 4, then 8,
Okay.
12, 16, 20, and this list will go on and on. I'll just put a dot, dot, dot here. Okay, what about the multiples of 3?
I know this one, and I even know a cool song that goes with it. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
I have not heard this song before. Okay, I'm going to go ahead and start with 0 here. We could talk about negative numbers, but we're going to stay away from that for now. So 0.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
All
and
right.
all through elementary grade, anytime something was times by 3, I would sing that song in my head.
You know, that one just hasn't made it into the popular culture, but I'm sure you'll be the one to take it there, Science Mom. All right, now, harder question. Which numbers are multiples of both 3 and 4?
Is it the same thing as asking what numbers are multiples of 12, or is it not the same?
You already figured out the answer. Yes, It is the same as asking what are the multiples of 12, or it's the same as saying what numbers showed up in both lists.
In both lists.
And yeah, so 0 definitely showed up in both lists.
12.
12. And then I didn't write it, but the next number in both lists would have been 24. And then 36. And this would go on and on. Nicely
Why
done.
do we care about knowing what multiples are? Does this help us with our multiplication skills if we...
Absolutely, and because we're going to be factoring, we need to be able to break these numbers down into smaller components, and we've seen that with addition already, but with multiplying, there's also a fundamental structure of numbers that we need to understand to answer a lot of questions. All right, so when we have two numbers that multiply to be 30, we would say that that's a factor pair of 30, and those two numbers would be factors.
Okay.
So for this problem, we want to find all the possible factor pairs for 30, and we're even going to draw a picture to represent a region that this factor pair is determining. Okay, so what two numbers might multiply to be 30?
3 and 10.
3 and 10, I like it very much. So I've got my little grid here. I'm going to draw height 3 and a width of 10, get me a rectangle here.
Okay.
So I'm just going to say that one's 3 by 10. Or the number sentence here, 3 times 10 equals 30. So we found one factor pair for 30.
5 and 6 is another one.
5 and 6, I like it. So I'm going to draw a height of 5 and a width of 6. So I can do this. All right, 5 and 6, so 5 times 6 equals 30.
Mm-hmm.
Any others?
2 and 15.
2 and 15. I like it. So I will do that one in green here. So height 2 and a width of 15.
That also equals 30.
Yep. So 2 times 15 is 30.
Mm-hmm.
Okay. Any others?
That's all I know. 2, 3, 5. Yeah, I think that's it.
So there's one other way to make a
Uh-oh.
rectangle of 30 blocks.
Oh, 1 and 30.
1 and 30 is correct. So let's try drawing that out. So it's got to be 1, 5, 10, 15, 20, 25, 30. I think I drew that the right length.
That's a very skinny box.
That's right. It measures 30 by 1, and it turns out that
1 times
30
30
times 1, or yeah, 1 times 30
is 30.
is 30. And also, that brings up a good point. 3 times 10 versus 10 times 3. We could say, okay, that's the same rectangle. We found the pair, and sometimes we might care about the order, and sometimes we might not. But I'd say for now, we've certainly found the right way of getting all the possible factor pairs for 30. And notice then, it's the same question when we ask for the factor pairs for 30 as saying, well, what rectangles can we draw with whole number sides that would give us 30 units of area? So we want to be able to find multiples of a number, and we also want to be able to factor a number. And one of the key skills in doing that is to recognize which numbers are, say, multiples of 2, or multiples of 3, multiples of 5, and so on. So let's list some of those characteristics. So how can you tell if a number is a multiple of 2?
Okay, so it has to be even. And that means that the last digit is either going to be a 0, a 2, a 4, a 6, or an 8.
Good. Multiples of 2 end in 0, 2, 4, 6, or 8. And that's correct. If a number ends in one of those, it's a multiple of 2, and if it doesn't, it's not.
All right.
All right, what about multiples of 3? How can you recognize whether a number is a multiple of 3?
By singing my song. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. But if it's bigger than 30, then you're in big trouble.
That's right, because we could write out a 7-digit number, and it'd be a lot harder to tell whether it was a multiple of 3 if you're going off Science Mom's song. So let's have a backup plan in mind. And for that backup plan, I want to point out this really cool fact. Multiples of 3 have digits that sum or add up to be a multiple of 3.
I remember this. I had totally forgot about this, but I remember this now. This is a really cool fact.
It is. So if I named a number like 45, there are 2 digits.
4 plus 5 is 9. 9 is a multiple of 3. Therefore, 45 is a multiple of 3.
That's right. And if I named a number like 62,
6 plus 2 is 8. It is not a multiple of 3.
yeah, 62 is not a multiple of 3 because the digits add up to 8, which is not a multiple of 3.
That's pretty cool.
Okay, what
So
about...
see, my song is useful. Because if you add it up and it's either a 3 or a 6 or a 9, then you're all set.
That's right.
3, 6, 9.
It all comes back to the song in the end, but this rule will help power you through. All right, multiples of 5. How can you tell if a number is a multiple of 5?
It's going to end in a 5 or a 0.
Yep, so multiples of 5 end in 0 or 5. All right, multiples of 6.
I have no idea.
Well, if it's a multiple of 6, then it has to be a multiple of 2, and it has to be a multiple of 3.
This is true.
So really, we would just use those first 2 rules up above,
Both together.
both together. So it would have to end in a 0, 2, 4, 6, or 8, and the digits would have to sum to be a multiple of 3. So multiples of 6 are multiples of 2 and 3. So you have to combine those first 2 rules to determine whether a number is a multiple of 6. Okay, I'm skipping to 9. How can you tell if a number is a multiple of 9?
I wonder if it's similar to the multiples of 3 rule, because 9 is
That's
a
right.
multiple of 3, but I'm not sure.
You're exactly right. Multiples of 9 have digits that sum to be a multiple of 9. So, as an example, I'll just write up a number here. What about 347?
All right,
So-
7 plus 4 is 11, plus 3 is 14.
And is 14 a multiple of 9?
Nope.
Nope. So yeah, when you do 3 plus 4 plus 7, this is not going to give you a multiple of 9, so 347 is not a multiple of 9. Multiples of 10. How can you tell if a number is a multiple of 10?
I know this one. This one's easy. It's going to end in a 0.
Yep, multiples of 10 end in 0.
All of them?
All of them.
Prime numbers.
That's right. We're going to talk about prime number science, Mom. Do you recall what a prime number is?
A prime number is a number that does not have factors besides 1 and itself.
That's right. So another way of thinking about prime numbers, there's only one way to draw the rectangle that has that many blocks.
Ooh.
So here I drew 6. So 6 is not prime because I can break that up and redraw it as a different rectangle. So 7 would be prime, 6 is not prime. We call it a composite number because there are different ways of drawing that rectangle, or there are different factor pairs.
Mathematicians really like prime numbers.
We do. They're the
Yep.
fundamental building blocks. So if we understand how numbers are built out of primes, and we understand the prime numbers well, wow, well then we have a whole arsenal of weapons at our disposal. Okay, Science Mom, is 132 a prime number?
No, because it ends in a 2, so it is a multiple of 2, so it can't be prime.
Okay, and that's all we have to do is find some factor other than 1 or the number itself, and that would be enough to say that it's not a prime number. So 132 is not prime because 2 is a factor of 132.
But 5001? I'm going to guess that that is prime
Okay,
because it ends in a 1 and it's not divisible by 2.
so it's not
or-
divisible by 2. I like
Oh,
that.
but it is divisible by 3 because 5 plus 1 is 6.
Oh, so
So-
even though that's a huge number, and you might not have any idea what factor pair you get, you can, if you find one factor, then you know that there's going to be something else to go with it to fill out the pair. All right, so 5001 is not prime because 5001 is a multiple of 3, or 3 is a factor of 5001. Okay, 91. Is 91 a prime number? So it's not too large.
It's an odd number. That means it's not divisible by 2.
I agree.
9 plus 1 is 10, which is not divisible by 3. So it's not divisible by 3 either. It's not
Okay.
divisible by 5 because it doesn't end in a 0 or a 5, or by 10.
Ooh.
I'm going to go ahead and guess that it is prime.
So it turns out 91 is not prime.
Not prime.
Nope, 91 is 7 times 13.
Oh, sneaky 7.
Yeah. So there is a rule for telling whether numbers are multiples of 7, but boy, it's such a complicated rule, it's almost easier to do long division.
Do you have to check all of the factors all the way from 1 to 90 to try and figure out if it's prime? How do you know when to stop checking?
Okay, well, that would certainly do it, although it turns out you don't have to go up until you get to 91. Go up till you get a number times itself is bigger than 91, and then that's as far as you have to go. All right, Science Mom, I'm going to write out the numbers 1 through 20, and we're going to see if we can identify which of them are prime numbers. Now, Science Mom, I want to find all the prime numbers up to 20.
Okay.
And I'm going to start off by crossing out the number 1. We don't consider the number 1 to be a prime.
1 is not prime. So
Right.
you want me to cross off all the other numbers that are not prime?
Yeah,
and
but
then
let's-
circle the prime numbers?
That's right. The ones that will be left will be the prime numbers.
Okay. So 2 is definitely a prime number,
That's right.
and so is 3.
Okay, well, let's actually go stick with those multiples of 2 for a moment. So 2 is prime. What ones do you know are not prime just from that fact?
Oh, I know that anything that is a multiple of 2 is not prime.
Aha.
So 4, 6, 8, 10, 12, I can just go and get every other one.
That's right, you can cross them off. We know that they will have a factor pair that involves a 2.
Yeah.
Okay, so then you said 3 is prime. That's correct.
Time for the song. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
Yeah, so you can cross off all the multiples of 3. Okay, 5 now.
5 is prime.
Agreed.
And that means that 10 and 15 and 20 are not prime, but I already have them crossed off my list.
Okay, 7.
7 is a prime number, and that means that 14 and 21 are not going to be prime because they're multiples of 7, but they're already crossed off as well.
Very good.
11 is prime, and at this point, can I just say anything not crossed off is prime?
Actually, the ones that are left are all prime. That is true. Those are all the prime numbers up through 20.
2, 3, 5, 7, 11, 13, 17, and 19.
That's right.
Cool.
In the worksheet, I've asked you to find all the primes up to 100. I hope you're up to the challenge. Ooh, this is a fun challenge problem. We have a 5-digit number, 61,730 A.
A?
A, yeah, A is the name of our last digit there.
Okay, we don't know what it is.
That's right, it's got to be 0 through 9, but we don't know which one. But that's the question. What is A? All we know is that this number is a multiple of 9, so how could we figure out what A is?
We'd have to add up all the digits. So 6 plus 1 plus 7 plus 3 and see where they're at and see what we need to add to them to get a multiple of 9. Is there more than one answer?
Let's find out.
Okay.
So this has to be a multiple of 9, but let's add them up. 6 plus 1, so 7 plus 7 is 14, plus 3 more is 17 plus A. That has to be a multiple of 9. So 17 plus A, can you think of any multiple of 9 that's close to that?
18. So 17 plus 1 would be 18.
So A could equal 1. Could A be any other number? Well, what's the next multiple of 9 after 18? We'd have to jump up to 27.
Yeah, we can't get there with one digit.
No, we can't get there with just one digit number, so A has to be 1.
Ooh.
So that means that this number was 61,731. That's the only possible answer because we had that bit of information that it was a multiple of 9.
Nice. I like that challenge problem.
I hope you do, because here come some problems
Whoa.
for you. Let's see if Science Mom learned today's lessons. We want you to find all the factor pairs for the number 24 and then even draw out rectangular regions that
Each
these factor pairs could represent.
All right, I like this question because the way that I'm thinking about it is that I just need to start with a very long, skinny one. So 1 times 24 equals 24, but I also know 24 is it's divided by 2 because it ends in a 4. It's an even number. So my next box is going to be 2 by 12, which equals 24. And then next I'm going to do 3 because 4 plus 2 is 6, which is a multiple of 3. So I can do 3 times 8, which equals 24.
Good job.
And then the question that I'm going to be getting to pretty soon is, when do I know I'm done? And I think I know I'm done when I get as close to a square as I can be with my box.
That's exactly right, Science Mom.
4 times 6 is 24, and then if I want to make my rectangle narrower, I'm just going to reverse and go the other direction. 6 times 4.
That's like rotating the box onto its side.
Yeah.
I like it.
And so I know that I did all of them because I got as close to as a square as I could.
And you also explained why you don't have to check all the possible numbers 1 through 24 to see if they are factors of 24. So if you were trying to decide if a number was prime or not, really you just have to go up until you would get a square box that is that size, and then you've checked all the possible boxes.
Oh, cool.
Yep.
I'm ready for my next challenge.
All right, Science Mom. Is 61 a prime number?
And I can't just pick up my phone and ask my phone, because my phone will tell me.
It could, but yeah, your phone's not going to do all your thinking for you in life. So.
Okay, is 61 prime? So I will just check, is it divisible by 2? No.
Okay.
Is it divisible by 3? 6 plus 1 is 7, so nope. Is it divisible by 5? No. Is it divisible by 7?
I like that you're only checking the prime numbers. Like you skipped over 4, for example.
Yeah.
Because if it's not a multiple of 2, it couldn't be a multiple of 4.
Mm-hmm.
All right.
Is it a multiple of 9?
So 9's
No.
actually not prime, so we didn't need to check it, but okay.
I'm just, multiple of 10. Nope.
It turns out we've gone high enough. We don't need to keep going all the way up to 61.
Because 10 times 10 is 100. So
That's right.
that's how we know we've gone high enough.
We're already past 61 at that point. So
In fact, at 9 we were past 61, because 9
right.
times 9 is 81.
yeah, 9 wasn't a prime number, 10 wasn't a prime number. We didn't even need to test them, actually, but that's okay. That certainly doesn't hurt. It's a good sanity check for us. All right, but you left a question mark next to that 7.
I did. Because you didn't tell me how to check if things were multiples of 7.
No, you're going to have to do this one the hard way. So if we were to count by 7s, what numbers would be hit near 61?
Okay, so 7 times 7 is 49.
That's right.
7 times 8 is 56.
Aha.
And 7 times 9 is 63. And since 7 times 9 is 63, I know that 61 is not a multiple of 7.
That's right. We skipped right over 61 when counting by 7s. So the final answer is 61 prime?
Yes, it is.
That's right. 61 is a prime number. Well done, Science Mom. But can you handle this huge number, 123,454,321? Is it a multiple of 9?
Ooh, I can indeed, because I just need to add up the numbers. 1 plus 2 plus 3 is 6.
Good.
And then I'm gonna add them up in groups and then add them together just for fun.
Okay, I like this approach.
So 9 plus 4 is 13.
Good.
And then we have 3, 2, 1, which is exactly the same as the other one. And I know that 6 plus 6 is 12. So 12 plus 13 is 25.
So if we were to add up all 9 digits of that number, we would get 25.
And 25 is not a multiple of 9.
No, it is not. Therefore,
This number is not a multiple of 9.
that's right, the big number is not a multiple of 9.
A special thank you to our patrons who made this video possible.
Join us at patreon.com/sciencemom to support more videos like this.
And don't forget that there are worksheets in the description that you can download.
Work hard, grow smart, and we'll see you next time.